Okay, right. Today we are going to continue with negative binomial distribution. Hopefully you all got on pretty well with that on whatever day that was. Then Wednesday. Today's Monday. Anyway, we're going to look at the mean and the variance of a negative binomial distribution. Okay, so if we've got a x which is negatively binomially distributed with r as our successes and p is our probability, then the expectation, the expected value, the mean of x is r over p. Okay, the number of successes divided by the probability, and the variance, which we give as var x or sigma squared, is r lots of 1 minus p over p squared. Obviously, be careful if it asks you for the standard deviation, i.e. sigma. We are doing the square root of the variance. Okay. Right, so Paul and Dan play noughts and crosses. The probability that Paul wins is 0.7. The random variable x represents the number of games that they need to play for Paul to win 7 times. Okay, we're going to first of all find the expectation and the variance. We're then going to, then they change the games and start playing chess. The random variable y represents the number, I'm not sure why it represents the number of games that they need to play for Dan to win twice. Given that the mean of y is 6, find C, Dan's probability of winning any single game of chess and the standard deviation. Okay, so here we go. I'm going to do this, try and keep both of them on the screen at the same time. Here we go. So Paul and Dan play noughts and crosses, and the probability that Paul wins is 0.7, and we want to know how many games they need to play for Paul to win 7 times. Okay, so if we say x is the number of games they need to play, x is binomially distributed with a r of 7 because we need Paul to succeed 7 times, and the probability he does succeed is 0.7. Okay, don't forget you get a mark for setting up your distribution. That is us setting up our distribution. Okay, we have been asked to calculate the mean. The mean is e of x, and we learned earlier that that is r over p. So r is 7, p is 0.7. Shove that into your calculator. The expectation is 10. So that is saying that because the probability that Paul wins is 0.7, the number of games of noughts and crosses that we'd expect Paul and Dan to have to play in order for Paul to win 7 times would be 10. Hopefully that makes a bit of logical sense. Okay, it's then asked us to calculate the var. For x, var is r brackets 1 minus p over p squared. So that is 7 lots of 1 minus 0.7 over 0.7 squared. Chuck that in our calculators. 7 times 0.3 over 0.7 squared is 4.286 to 3 decimal places. Okay. We've only been asked to calculate variance. We don't need to calculate the standard deviation. Okay. Right. They then change games and start playing chess. And the random variable y represents the number of games they need to win for Dan. Can we see that? They need to play, for Dan to win twice. Okay, so y is the number of games of chess they need to win, and we need Dan to win twice. So our r value is 2. We don't know what our p value is because we haven't been given it. Okay, we have been told that the mean e of y is 6. So given that e of y is r over p, we know that that means that 2 over p must equal 6. So therefore p must equal 2/6, which is a third. Okay, so that means the probability of winning a single game is a third. Okay, and then question D. I probably would set up my negative binomial distribution so that I've got it written down. So it's like that. Then we want the standard deviation. So we're going to need to do the variance of y. The variance of y are 1 minus p over p squared. So that is 2 times 2/3 over 1/3 squared. That comes out to be I'm going to put that over a 9th because I can do that in my head. That is 12. So the variance is 12, which means our standard deviation is the square root of... Oh, my laptop's just come off. Let's hope we're all still intact. So that is 12, and that means that my standard deviation is the square root of 12, which is obviously 2 root 3, which is 3.4641, blah, 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 blah. Okay? That is the standard deviation. So now we should be able to do exercise 3D.